Hi math students, it's Miss Carol. We are now working on the Unit 3 project. We are on Lesson 11, and in this lesson we have 7 questions, so I'm going to just jump right in so that we can get started here. The background for this is working together. When building things in the real world, it is important to know all of its key features. Often structures such as archways, playgrounds, or buildings are designed first, then built as a scale model from which they are then built in real life. Architects were hired to redesign a local community center. They wanted to create a new playground and remodel the doorways. Use your knowledge about factoring expressions to answer the questions. Okay, question number 1. Two integers m and n have a sum of -5 and a product of -24. Which of these polynomials factors as x plus m and x plus n? So basically what we are looking for is we don't even have to figure out the factors here. All we have to know is that the product one is going to be the last number and that the sum one is going to be the middle number, okay? So I had made some notes here, so I want to make sure we get this right. So when we are doing the FOIL method, if you remember, the first, outer, inner, last. Okay, the last two terms multiplied together are going to give us that last integer term, or if we're looking at it from ax squared plus bx plus c, it's the c term, okay? And so we need to find one of these answers with the c term as -24. So let's narrow it down. It's going to be one of these, okay? And then the b term is going to be -5 because the b term is the outer and inner terms added together, okay? So when the b term is -5, we're here. Notice that I didn't even have to come up with which values gave me a -5 when I added them together and -24 when I multiplied them. All they wanted was for me to come up with that ax squared plus bx plus c based on that information. So x squared minus 5x minus 24. Okay, question 2. In the previous problem, what are the values of m and n? So like we, like I just said, when I didn't have to find those values, now I do. So remember, it was x squared minus 5x minus 24, okay? So I need two numbers that when I multiply them together, I get -24, and when I add them together, I get -5. So let's first come up with the factors of 24. I think that's an easier way to do it than figuring out all the possible numbers that could add up to -5. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And if I go higher than that, I just end up with 6 and 4, 8 and 3, okay? Now, all of these together make 24. If I were to add any combination of positive and negative numbers here, can I make 5? So if I had a -1 and positive 24, I'd get 23. -24 and positive 1, I'd get -23. -2, positive 12, I get a 10. -12, positive 2, I get a -10. -3, sorry about that. -3 and 8, I get 5, but -8 and 3, I get -5. So that's what we're looking for is a -5. So these two numbers, 3 and 8, when the 3 is positive and the 8 is negative, when I multiply them together, I get negative 24. That's for multiplication. Okay, but when I add them together, I get negative 5. So that's exactly what we're looking for here. So my answer here is going to be negative 8, 3. And I'm not sure if there's a space in there or not. Don't worry about it. I grade these, so I'll have a chance to look at that. Okay, so moving on. The area of the playground is x squared plus 12x minus 45. Which of the following represent the length and the width? Okay, so remember, area equals length times width, right? And we know that a polynomial or a quadratic equation like this is the product of two binomials. So we know that it is going to be something like x plus, we'll do the m and n again, x plus m times x plus n, okay? Where this quantity represents the length and this quantity represents the width. Okay, so now we just need to come up with two numbers that when multiplied together give us a negative 45, but when added together give us a positive 12. Okay, so I'm going to do the factors of 45. 1 and 45, 2 doesn't work, 3 and 15, 4 doesn't work, 5 and 9, 6, 7, 8 don't work. So these are our factors of 45, okay? Do any of these, when I multiply, when I add a combination of positive and negative together, do they give me 12? Well, I can see right off the bat here that if this 3 were negative and I added it to a positive 15, gives me a positive 12. But when I multiply them, a negative 3 times a positive 15 gives me a negative 45. So what that is saying is that my factors are going to be x minus 3 times x plus 15. And I can double check this, okay? So if I use the FOIL method, I get x squared. O is negative 3x, I is 15x, and L is negative 45. These combine to 12x, and I end up with x squared plus 12x minus 45, which is what I was looking for. So my two factors that I came up with are x minus 3 and x plus 15. Okay, question 4 says, let me move this out of the way. Use your answer from the previous problem, and then which of the following are true about m and n? So, all right, when I add m and n together, remember, this is how we solved it actually. So m and n added together is going to give me 12. And this is exactly what we came up with in the previous problem. And m and n multiplied together give us negative 45. Okay, so hopefully that was really obvious in the previous problem. It almost seems like this one should have come first. Okay, question 5 actually. Anthony and Bativa are working on a building model of the new playground. Together they can build the model in 10 hours. If they each worked on it individually, it would take Anthony 15 hours longer than it would take Bativa. Their hourly production rate can be given by the equation 1 over A for Anthony plus 1 over B for Bativa equals 1/10. Because if they can do it together in 10 hours, then each of their quantities added together is going to be 1/10 of an hour, right? So if I want to substitute in B for A, okay? If I want to say, what does A equal in terms of B? Well, remember right here that it takes Anthony 15 hours longer than Bativa. So A equals, if they were to do it all by themselves, okay? A equals B plus 15. So if I want to substitute that in to this equation, all I need to do is this right here. I just put B plus 15 in for A. Easier than it looks, right? Okay. Question 6. Some algebraic manipulation of the equation from above gives us this equation, b squared minus 5b minus 150 equals 0. So we need to factor this just like we've been doing. Okay, so we need two numbers. When we multiply them together, give us 150, and when we add them together, give us a -5. So one thing that, well, let's just see if we can come up with the factors of 150. You might see it right away, but let's do 1 and 150, 2 and 75, 3 and 50, 4 won't go in there. Let's see, 5 goes in 20 and 10. Oh, of course, 5 and 30. 6 is going to go in there because 30 does. Let's see, if 6 goes into 35 times, so it's going to be 25 and 6, of course. 7, 8, 9, 10, and 15. That's about as good as we're going to get, okay? So if you see any of these with a difference of 5, imagine a difference of 5. And the only one where there's a difference of 5, if I said 10 minus 15, I will end up with a -5. But if I multiply them by each other, I will get a -150 as long as one of those quantities is negative. All right. So that tells me that I am going to have x plus 10 times x minus 15. All right. If I FOIL it out, I get x squared plus plus 10x minus 15x. I did those two backwards, and minus 150. So when I combine these, I get minus 5x. So we will just type that in here, x plus 10 and x minus 15. All right. Last question, explain how you completed the factoring for the previous problem. How do you know you are right? So in the interest of time, this is what I would put here. We listed all the factors of 150, and we found the two factors that have a difference of 5. And then we can verify that we are correct by using the FOIL method with those two factors to see if we end up with the quadratic equation that we started with. So you're welcome to add some to that if you'd like. If you maybe have a different method of doing that, I'd be totally interested in that. But that's all I have for lesson 11. Thank you for joining me.